If we want to find the area of a region between two curves, then I'm going to go ahead and give you the whole point of the lesson right here. Top minus bottom. That's it. Top minus bottom, top minus bottom, top minus bottom, top minus bottom. There it is. That's the most important line in the whole lesson. That'll come in really handy later. Even if it's below the x-axis, top minus bottom. That's it. So let's jump into it. Consider the region bounded by that graph on that interval and find its area. Okay, so I'll go ahead and tell you a hint. That's what this is. This is the graph of f of x on the interval that they gave us. So this is f of x. Gave us this, and I want to find this area. How would I do it? Well, glad you asked. I would find the integral from 2 to 6 of negative x squared plus 8x minus 9 dx. And we can do this by hand, and it would be fun, and it would be fantastic, but it would be a waste of our time, so it's not worth the trouble. So let's just type it in the calculator and do it. And I'm going to do it graphically. Normally we could press math and 9. We could do that. That's cool. Oops, not from there. Well, you could, but let's not. We could do math 9. I'm not. I'm going to go graphically just because it's kind of neat to do that. So let's press y equals, and let's type it in there. Type this in there. So negative x squared plus 8x minus 9. You know what? I'm going to go ahead and type the next one too. So the next one is g of x. Hint, hint, hint. This one's going to be g of x. Just throwing that out there. So g of x is going to be 1/2 x squared minus 4x plus 9. And we're going to graph them. And let's not graph f yet. Let's not graph g yet. So we're going to graph the first one. Notice I turned off the equal marks on the g. So let's go to window. I'm going to graph it based on what we see right here. So we're going to go from 0 to 6 and zoom fit. And we're going to see this right here. Actually, we're not. We're going to see a little bit too much, but that's okay. So this is that. It just is scaled a little bit differently, and that's all right. And then we want to find the area between 2 and 6. So we press second calc, and we can see this right here, the integral. And the lower limit is 2. The upper limit is 6. And it has shaded it in. It is exactly what we see here. Again, just scaled differently. And the answer is 22.666666666. So it is 22.6. Repeating, that is 22 1/3. I'll just leave it as a decimal for now. Okay, now we're going to do this one. And when we do, it's going to look like this. Let's turn that one off. Let's turn this one on. And we'll go to zoom 0. And we see this one. We want to find that area. This isn't showing up what I want it to show up. Listen, I'm going to adjust this. I'm going to do it the way I want to. I'll fix my window how I like. 0 to 6 with a scale of 1. The y is going to go from 0 to 4. With a scale of 1, we'll graph that. There we go. This will be more consistent with what we see here. And it is. And we're going to figure out the area from 2 to 6. Second calc. Number 7, our lower limit is 2. Our upper limit is 6. And we see that big red space right there. And the answer is 6.6666666. That is 6 2/3. I'm going to write it as an integral. It's just good practice to do that. So the integral from 2 to 6 of 1/2. I can get my ones right. 1/2 x squared minus 4x plus 9 dx. And that is equal to 6.6. Repeating. Find its area. Well, we did. All right. So now we are left with this ridiculous shape over here. So now it's the third question. Consider the region bounded between the graph of f and g on the interval from 2 to 6. What? What do you mean? Okay, so this top one right here was f. And we found all this area under here. Okay? And this under here was g. And we found all this area under here. So I'm going to write an equation. This is going to be cool. This whole area minus this little under piece equals that one. That's it. So find its area. All right, done. All we have to do is say, well, 22.6 repeating minus 6.6 repeating, and we really have 22 minus 6, and that's going to give me 16 square units. Okay? I want to show you calculusically, that's not a word, I want to show you with calculus what that really looks like. It is the integral from 2 to 6 of, let's not overcomplicate things, it's f of x minus g of x. dx. And we have a lot going on here, multiple terms, so let's put it in parentheses or brackets. And that is what it is. That's all in the world we do. Notice we just did top minus bottom. Top minus bottom on a given interval. So now we slide to the next problem and we'll go from there. Find the area of the region bound between the graphs. Okay, we don't know what the graphs look like, but we know it's between them. So it's going to be this thing where we have some graph and some other graph, and we really want to find out what's between them, which ends up looking like this. In this case, it's going to be something else. So we're going to graph these by hand, and that'll kind of give us a little bit of an understanding of what's going on. I'm going to go ahead and do the one by hand. It's really easy to do. So the g of x equals 2. So g of x equals 2 is going to be a horizontal line at 2, and I really, really hope you know that because this is calculus. So there we go. G of x equals 2, and this is the function g of x. All right, cube root of x plus 2. The cube root is a funky looking little thing, and I do want to get some points exactly right and the contour of it exactly right. I know this is a point. I know if I plug in a 1, I'd have 1 plus 2, so that would give me a 3. I know that's a point. That's the only one I could do like 8, but that's not on there. So I'm going to get the general shape of it somewhat right here. So clear those out. So math and cube root of x, and then plus 2. Plus 2 is not under the cube root. That's important. And we will adjust the window from 0 to 6, and we'll zoom 0 this thing. There we go. There's a general shape to it right there. I'm going to find out a couple more points. Let's get, let's see, 2 is at 3.2 something. Wait, this is wrong. 1 is at 3. Ooh, that's 1. Whoa, I was wrong. 2 is at 3.2 something. And 6 is at 3.8. So it's got this little curve to it about like this. It does like that. Okay. And I want to figure out the area of the region bound between them. Okay, so we used to be finding the area bound between a graph and the axis. We're really doing that now. So watch me as I shade too much. Don't do this. If I wanted to find the area between this curve and the x-axis, I would color all that right there. And it would be fun, and we'd have a wonderful time. But I want to figure out the area bound between them. So why don't I find that whole area and then subtract this one? There we go. This is what I'm finding. And notice it stops at 4 because they said so. They tell you the intervals sometimes. Sometimes they don't. And that's the fun part. And we're just going to figure out what this is. This curve is f of x. There we go. All right. Let's figure it out. This one actually is doable by hand, but we're not going to. We could use a fundamental theorem of calculus on this. The interval 0 to 4, because they said so. Excuse me. And we are going to have the cube root of x plus 2 minus the other function, 2, dx. Now, you see the obvious. I see it. You see it. You know what's happening here. So technically these cancel, and what I really have is 0 to 4 of the cube root of x dx. And that's it, same thing, all right? But the point is this. This component right here, these two terms, that was f of x, and this was g of x. And it was top minus bottom, and it's that easy. And we could do this by hand, but that is not the point of this lesson, so let's not. So here goes math 9, 0 to 4 of the cube root of x with respect to x, and we get a number any second now. There we go. Now we would have been able to find it by hand, but we would have had cube roots in our answer. So 4.762 square units. All right, let's do this next one. Find the area of the region bound between the graphs of f of x equals 1/4 x and that should say g of x equals 1 over x plus 1 on the interval that begins at 1 and ends at their point of intersection, and sketch a graph. Okay, so let's sketch a graph, and we can do the first one relatively easily. So this is a line, slope of 1/4, and you know what to do here. So We'd rise 1, and we'd run 4, and there it is, right there. And this is our first line. And when we graph this one, we don't have a y-intercept because x can't equal 0, so that's kind of important. There's an asymptote there. So we'll sketch a few points on this one and kind of see what happens. Actually, let's go ahead and plug in a 1. So we plug in a 1, we get a value of 2. Okay, so at x equals 1, we have a value of 2. I'm going to plug in a 2. At x equals 2, we have a value of 1 1/2. At x equals 3, we have 1 1/3, and then we get into some craziness. So let's not. All right, so let's graph this thing, see what it looks like, get a general shape for it. And 1 over x, I'm going to call it x to the -1, same thing. Plus 1, just a cool little trick to do. And we will go on the window from 0 to 6, because that's what we have here, and we'll graph. Whoops, how about we do, whoa now, zoom 0. Let's try that instead. Okay, well, that gives me a general understanding of its shape. Let's go to the table and get a few points on there. 4 is 1 1/4, which I kind of knew. 1 1/4. And then kind of levels off from there. So we have this. Now, I don't know where they meet. I really don't, and that's a problem. See, okay, so I want to find the area of the region bound between them. So we're in between them here. It begins at x equals 1. So it begins here. This is one of the boundaries. And it's going to end wherever they meet. And I don't know if I drew it very well. So I need to find out where they meet. So I have a couple options. I could set them equal to each other and solve it. Or I could do a little trick on the calculator and do it. Now I'm going to do the trick on the calculator first. So let me show you. Here goes. Y equals, and we have one of them typed in. Let's type the other one in, 0.25x. And we will go to window 0 to 6 and zoom fit. And it's graphing them both, and they're about to meet right there. Okay, well, I don't know where there is. It's here somewhere. And so I'm going to find out where exactly that is. Second calc, and I need the point of intersection. First curve, press enter, second curve, press enter, take a guess, yeah, whatever, you can guess. And the intersection is at 4.8284271, and it goes on and on. And so it's at 4.828 something. Now, we can easily run into some rounding error if we put, oh, it's at 4.828, and we never carry that value with us as we go, okay? So it is important that we know what this point is. The x value here, the y value is kind of irrelevant because all we need is the x value because that is our interval. And this x value is at 4.828. I'm not going to write anything else other than that. But here's what I do have. I'm going to quit from there. And I'm going to press X. The last X value that happened in my calculator was that. And I don't want to lose it. So I'm going to store it. Now, I know you're thinking, well, it's already stored as X. Yeah, I use X so much in the calculator that, no, it's going to be going real fast. So this X needs to store as something else. Call it whatever you want. I'm going to call it B because normally intervals go from A to B. So I'll just let that. And A would be 1. I'm not going to store that. So this, in all its computational glory, is stored in there. So I will not have rounding error from this point forward, not with that number. Okay, if you wanted to solve this by hand, you could. I'm having a gut feeling that this is really the square root of 8, and I think it is. So I'm going to sidetrack for just a second, and I'm going to see if that's truly the case. So 1/4 x equals 1 over x plus 1, and we'll solve it. And I think we can solve it by multiplying every term by x. So this side gets multiplied by x, this side gets multiplied by x, and that means I have 1/4 x squared. I have, oops, not plus, it's equal to 1, and then plus x. So we have 1/4 x squared minus x minus 1 equals 0. We have a quadratic. X squared minus 4x minus 4 equals 0. It's about to get real tricky, and we'd have to use the quadratic formula on this. And I'm going to make sure that I'm right really quickly. Pardon me as I sidetrack, but negative b plus or minus, we'll do plus. The square, yeah, it would be plus because the other one would be over here on this side. The square root of b squared minus 4ac all divided by 2. And I think, hold on, we have 4 plus, I'm pretty sure that this is close to the square root of 8. Having a hard time doing that in my head. That's irrelevant. Sorry to waste your time for the last 30 seconds. Okay, nevertheless, we have that. So where are we going to go with it? Let's get back to the original problem. Sorry I got sidetracked. I was having so much fun with algebra. We want to find the area between them. Slide all the way up to the top. Top minus bottom. Don't make it harder than it is. The area of this entire thing from here to the x-axis, minus this part under here. So f minus g. Is it always f on the top and g on the bottom? No. Actually, this one's g minus f. Haha, fooled you. So this one's tricky because g is on the top. Notice that this graph was g. This graph was f. So it's g minus f. You have to be careful with that. Let's put brackets around it. And it goes from 1 to 4.828. Don't type 4.828 in the calculator. We're going to type b in instead. Okay? So, let's see. I had g as my y1 and f as my y2, so we have to keep the order of that straight in our head, otherwise we're going to mess up. So we have math 9, 1 to what we stored as b, and it's going to be g minus f. Again, keep up with which one was stored in what place. There we go. 2.614 is that area right there. 2.614.